talked in the last video about what acids are and what bases are. This video, we're going to look at what happens when we mix acids and bases together.
Do they explode?
Sorry, sadly, no. Sometimes they'll bubble, though.
Ooh, bubbles.
All right. A neutralization reaction is what happens when we mix an acid and a base together. It's a special type of double replacement reaction, which you may remember from back when we talked about types of reactions. Because if you notice, we're starting with two different compounds. And we're going to end up with two different compounds.
Okay.
The nice thing with this is, because it's always between an acid and a base, we always know what we're going to get. We're always going to get a salt and water. And it actually ends up being really easy to predict our products because of this. Okay. So if we look at our reaction here, we've just got our reactants. We've got HCl plus NaOH. And thinking back to the last video, what did things starting with an H, what kind of substances were they?
Those are the acids.
Those were the acids. So let's label that as our acid. So A for acid. And then things with OH, we said were going to be what?
Those are the bases.
Those are the bases. So we've got an acid, we've got a base, so we can do a neutralization reaction. And the nice thing is we know one of our products has to be water. That water comes from taking the H from our acid and the OH from our base to make, what's the formula for water?
H2O.
All right. And so we know that our H went away for that.
All right.
And our OH went away.
Okay.
What does that leave us?
We've got the Cl and the Na.
All right. And so we know we can put those together into a compound. And if you think back to when we were doing ionic compounds.
Wow, that's way back.
Way, way back. We need to know our charges. What's the charge always on Na?
Na is in group 1, so it is +1.
And we know that Cl is in group 7, so it's always
-1.
And so if we've got a +1 and a -1,
we want them to cancel out so we can put them together. That means our formula is NaCl.
Right.
So the products are, there's our water that you said we got, and well, that's nice. We got salt.
Right. But the thing to keep in mind is, yes, sodium chloride is the kind of salt that we eat, but for chemists, salts are simply another thing we can call ionic compounds. So not all of our reactions are going to make sodium chloride, sadly.
And so we probably can't eat all of them either.
We can't eat all of them either.
Okay.
All right. So this is actually the bulk of what you need to know for this. So why don't you go try your guided practice on your own, and then come back and check and see how you did.
Alrighty. Okay, so I gave it a shot.
What was the easiest part to put down?
The easiest part to put down was the water.
The water.
Yeah.
So we know our first product is going to be water.
That was nice. And it came from the H and the OH. Okay.
Did it matter that you had two H's there, do you think? No, I guess not, because we had to make water. Right. Regardless of how many H's your acid comes with, regardless of how many OH's your base comes with, you're always going to make H2O as one of your products. Different numbers are going to just come back to your balancing later. We're not actually going to make you balance this time around. Just be aware that's why you're going to end up with different numbers of H's on both sides.
Okay.
All right. So what does that leave us?
Well, I'm left with K, which is in group 1, so it's +1. And SO4, that's one of those polyatomics. So let's see. Look at my handy dandy chart, and it is -2.
Okay, so we're going to cross our charges.
All right, so when we crisscross, I'm going to bring the 1 down there. I'm going to bring the 2 down there. So that means my products are the water, that didn't change, and K2SO4.
All right, and the one thing we actually didn't do, we skipped the easy part, which was identifying our acids and our bases.
Oh, yeah, that's right.
And remember, our acid was going to give us what?
That gives us the H.
Because acids are proton donors.
Right.
And then our base was?
The acceptor, so it had the OH. Sweet.
All right, so let's actually start with identifying our acids and bases on this next one.
Okay, so HBr is the acid, because it starts with H. That means CaOH is the base.
And we know our easiest product to make is going to be
water, H2O, and that came from that H right there and that OH. Now, I figured when I did that, it didn't matter how many OHs we had because it still has to make water.
Right.
Is that right?
This would become a problem if we were trying to balance, but just for figuring out what the products are, no matter how many H's, no matter how many OHs, it still makes H2O.
That's good. And that means we have calcium, which is in group 2, so it's +2, and Br, which is in group 17, so it's -1.
So we're going to cross our charges.
Crisscross, so then I brought the 2 down, and then the 1 down, so I've got a 1 and a 2. So that means the products, I've got water and CaBr2. That was actually pretty easy.
All right, now the next ones are a teeny bit more complicated, but actually really not that much.
Okay.
These are just asking us to predict what salt, and we said a salt was what?
A salt is any ionic compound.
That was going to be formed from the following acids and bases.
Okay.
All we're doing here is we're just giving the salt part, we're skipping the water part, because we know that everything makes water.
Okay. So if I want to figure out what if I want to figure out what the salt is, I can still say that the H and the OH make the water, and I can still put together what's left. So I've got Li, which is +1, and Cl, which is also +1.
Man.
That's funny, because it's not true.
Yes,
all right,
because
it's -1.
you have to put a plus and a minus together, because like charges repel, Mr.
Yes.
Thompson. All right, so now we've got a +1 and a -1, so what's our formula
so
going to
we can
be?
just put them together to make LiCl. So the salt between those two is the LiCl. And I just have to know that water is also involved.
Yep.
Okay.
All right, so now let's look at our next one. So this was HCl and LiOH. Now let's do H3PO4 and LiOH.
Okay, so I can still take out the H, because that's going to make the water. So now I've got Li, which is still +1, and I've got PO4,
which if we look that up on our handy dandy table, we find is
-3. All right, so then crisscross like that to give us LiPO4. Oh, no, Li3. Yep. PO4 is our salt. Okay.
All right, so same thing. Let's try HCl and
All right.
BaOH.
So HCl, H and the OH are going to make the water.
H
so
and the OH make the water, so that leaves us with
Ba,
which is in group 2, so it's a
+2.
and Cl, which we already said was a -1. And we're going to cross our charges.
Cross the charges. So come down like this and like this. So that's going to give us BaCl2.
There you go.
All right.
And last but not
then-
least, we've got our BaOH plus our H3PO4. We already know our H and our OH have gone away to make our water.
Yep, so we got Ba, which was still +2. The PO4, which was still -3. Going to go ahead and cross those. Bring them down. And that's going to give us...
I would go down.
BA3 parentheses, because it's the whole thing, PO4 2. So that's
Do be
our
careful with these
salt.
parentheses. Yep, that's your salt. So anytime you're trying to figure out what salt you're going to make, you take the H away from the acid, you take the OH away from the base, and put together what you have left over. So see, predicting neutralization reactions, really not
Actually,
that bad.
not too bad.
Yeah.
Alrighty.
So go forth, try your stuff on your own, ask your teacher if you still got questions.
Bye.